Okay, so we have two more free response questions to go through. This one was calculator inactive, and I think it was number 3. For this problem, they ask us to find the interval of convergence, and that is a common question on the AP exam. And so I just would really encourage you that you are able to do that. So one of the things you want to remember when doing this is notation is everything. And I did take off a few points if you did not note it correctly. So when we're finding the interval of convergence, we want to deal mostly with this expression. So we want to take the limit as n approaches infinity. Now, because we're dealing with absolute value, as I said before, we can sort of ignore the -1 to the n, and it's n plus 1, x to the n plus 1 over n plus 2, and then we're multiplying that by we're dividing that by the original. So we're dividing it by the original, which means we're going to multiply by the reciprocal. So this becomes n plus 1 over n x to the n. Okay, so as we're separating this, and all of this we want it to be less than 1. So we do the limit as n approaches infinity. And I'm probably writing this out more than I would if I were on the exam, just for so you could see it. So it's n plus 1, x to the n times x over, I'm going to put parentheses around this n plus 2 because some of the things I saw people do, over n times x to the n. Okay, so one of the things you need to know that as we go towards infinity, n plus n and n plus 2 look the same because as we go towards infinity, the 1 and the 2 are negligible. So 1,000,000,001 looks the same as 1,000,000,002 as we go towards infinity. So then I can cancel both of those out. The same thing for n and n plus 1. As we go towards infinity, they look the same. So that cancels and that cancels. So we're left with the absolute value of x is less than 1, which means that -1 is less than x is less than 1. Now, as you go through this, you have to check your endpoints. And checking your endpoints, you need to make it very clear that you're checking the endpoint. So I would do something like this. Check, and some of you did this. Some of you did this beautifully. Check -1. So to check -1, I put that back into the original expression. So I have -1 to the nth, n times -1 to the nth over n plus 1. Now, what I want you to see is that as we do this, the -1 and the -1, because they're both being raised to the nth power, we can write that as just -1 times -1 is +1. So this is +1 to the nth, which is not alternating. +1 to the nth does not alternate. So we have to ask ourselves the question, does n over n plus 1 alternate? And the answer to that would be no, because the limit of n over n plus 1, we've already said, is 1. It's not 0. So therefore, this diverges by the nth term test. Then we have to check 1. So that gives us -1 to the nth and 1 to the nth over n plus 1. Now, this is now alternating. This is an alternating series. So remember, it alternates if the limit is 0. But the limit still is not 0. The limit is 1, so this diverges as well. So our interval of convergence is -1 to 1, parenthesis, parenthesis. Okay? That was worth 5 points. 5 points. 1 for setting up the ratio, so that's your first point. 1 for computing the limit, so that's your second point. 1 point for identifying the radius of convergence, so that was another point. And 1 for checking both endpoints, and 1 for your conclusion. So that ended up being where the 5 points came from. And for most of you, it was feast or famine. You either got it all correct or you didn't get any of it correct. This next question I thought was pretty cute, but I don't think they're all cute. What it's asking you to do is it's asking you, they give you that y is equal to f of x minus g of x, that it passes through the point 0, negative 1, and they want you to find y prime of 0 and y double prime of 0. And then talk about its relative max or min, or neither. So the first thing we have to do is figure out what is f of x minus g of x. And we can, so the easiest way to do that, to find y prime, is to find f prime of x, which if we take the derivative, remember we can take it term by term. So taking the derivative here, I get negative 1/2 plus 4x over 3 minus 9x to the second over 4, so on and so forth. Now, when I evaluate that at 0, what I see is that because each term has an x, all of these terms would zero out, and I would be left with negative 1/2. So now let's try g prime of x. Actually, this is f, because I'm sorry, y is something else. That's f of x. So g prime of x, again, doing the same thing. The derivative of 1 is 0. So the derivative of the next term would be negative 1 over 2 factorial, and 2 factorial is just 2. And this would be 2x over 4 factorial minus 3x over 6 factorial, so on and so forth, so that g prime of 0 is also negative 1/2. So f prime of x minus g prime of x is equal to 0. Okay? Now we need to find the second derivative. So I think you got 1 point for this. To find the second derivative, we just differentiate this again. So we get f double prime of x. The negative 1/2, the derivative of that is 0, so then we get 4/3 minus 18/4 x over 4, so on and so forth. And g double prime of x would be, that is 0, so I'm going to get 2 over 4 factorial minus, did I miss something here? That's negative 1/2, that would be x, and this would be x squared. So minus 6x over 6 factorial, so on and so forth. And what we see that, again, as this goes to 0, so f double prime of 0 is 4/3, and f and g prime, g double prime of 0, this would go to 0, and I would be left with 2 over 4 factorial, and 4 factorial is 4 times 3, so 2 over 4 times 3 times 2, which is 1/12. So when they ask for the difference between the two, they ask, the graph passes through, determine whether it has a relative max or min. So it's just asking if it has a relative max or min, which is, does it ask you to actually find it? Determine whether y has a relative max or min. So I guess y double prime was 0, g double prime is 1/12. So y double prime would be 4/3 minus the 12. Now, is this a relative max or a relative min? And this is where the second derivative tests come into play. Because the first derivative is, when I subtract these two, did I do that? Yeah. When I subtract these two, I get 0. So my first derivative is 0. My second derivative is a positive number, which indicates that it is concave up. If it's concave up and the first derivative is 0, that means this must be, therefore it is a relative minimum. Okay? So where did the points come from? The points came from, this is worth 4 points. 1 point for finding y prime, 1 point for finding y double prime, 1 point for finding the relative min with the conclusion, with the reasoning. So there was 2 points to say that it was a relative min. And if you said it was a relative min, you had to show some work. Some of you did a sign chart, which was fine, but you had to show some work to support you saying it's a relative min. And then you got a 1 point for the correct solution, the correct conclusion. Okay? Let me know if you have any questions.